All right, we're going to get into inverses now of linear functions. And you may remember inverses when we learned about them earlier when we talked about switching x and y. X and y. Because if we look at a problem like this, in order for something to be a function, you may remember that it needs to be a one-to-one function. So just as a reminder, I think this is correctly done, is y equals mx plus b, that the slope is 2, the y-intercept is -4, and you can see it pretty clearly on the graph. Y-intercept is -4, up 2, right 1, up 2, right 1, so on and so forth. And how can we quickly remind ourselves if something is one-to-one is if it passes a horizontal line test and the vertical line test. And the reason why that's important is because we are going to take each one of these ordered pairs and we need to switch x and y around. So like the ordered pair 2, 0 becomes 0, 2. Same thing with this ordered pair, 1, -2 becomes -2, 1. And that's all that we're doing for this letter B, is reminding you that you can switch your ordered pairs. And if you need to, go ahead and write out all the ordered pairs, like 3, 2 becomes 2, 3. But after you do just a few points, you can probably see the behavior of our inverse. Looks something like that. And I could even confirm down here we had -1, -1, 2, 3, 4, 5, 6. And then over here we have the ordered pair -6, -1. So what we're supposed to notice with this is that the graphs of this and its inverse, which I have not shown you how to come up with just yet, we're about to, is that they are reflected over that line of y equals x. I'll go ahead and write that out, over y equals x. And that should make sense because if you just switch like 0, -4 to become -4, 0, it's got to just be flipped over something. And if you notice, I'll just put like a dashed line in here. You see how it's like 2 diagonals away? Well, it should also be 2 diagonals away on the other side. And now that we've come up with the correct graph, what you should notice about this is you can quickly identify what the slope is of this problem. I don't know if it's obvious to you guys, but if you look closely at the slope, it's going up 1, right 2, and we would write it as this, 1/2 x, and then plus the y-intercept is 2. Now, it might not be as obvious to you about what the equation of the inverse would be in this form, but what I could do is get the same denominator. So what that would come out to be is like x over 2, because that is the same thing as 1/2 x, is x divided by 2, and then change 2 to be 4/2. And the reason why we could write it that way is then we could say, okay, well, my answer would be x plus 4, and with the same denominator, I can combine them together now to be like this. And let me get to the point on this problem, whether or not you realize it, is what you're doing is you're doing the inverse operations of these two pieces. And what those two pieces are, instead of multiplying by 2 and subtracting 4, well, you would have to add 4 first and then divide by 2. Now, if you want to work this out by hand, what you're going to do, I'm going to write it down even though it's already on your notes right here, is you switch x and y. Well, we've already seen that before. And then what you do is you solve for y. And what I want you to practice as well is to write it in the inverse notation. So I wrote it out. Those are your 2 steps. And it's already in your notes. So if you have a highlighter, if you just want to box around this, this is what we're going to be practicing with all of these linear functions. So when I ask you to come up with the equation of an inverse, what I need you to practice is switching x and y. That's step 1. So it becomes x equals 5, y minus 20. And then I need you to solve for y. So your first step would be to add 20 to the left side. And when you solve for y, you're going to divide both sides by 5. Now, if you notice, none of my answers are simplified like that. So another way of doing this is dividing each piece by 5. And you never know what I'm going to ask you to do. So you might have it written in a lot of different ways. And eventually I'm going to get you to a point where instead of writing as y equals, this is your correct answer, because 20 divided by 5 reduces to 4, and x divided by 5 is the same thing as 1/5 of x. But I also will ask you to write it in inverse notation. So after you solve for y, I'm going to have you rewrite it as f inverse of x of 1/5 x plus 4. But right now, we're at option 4. So we're going to do the same thing over and over again. Just every problem is just a little bit different. And so, switch x and y equals 2/3 y plus 8. Solve for y. So subtract the 8 over. Now, instead of just dividing everything by 2/3, I'm a bigger fan of having students multiply by the reciprocal. You're going to hear me saying that all year long. So multiply both sides by 3/2, and as you distribute that in there, I hope you can solve this in your head. So pretty clearly it's 3/2 x. I think all of you would cross off options 3 and 4, but then you might mess up because it's 8 times 3 is 24, divided by 2 would give you -12. So we're looking at option 2 there. Just for the record, as we move on, I'm eventually going to ask you for the inverse notation. So the inverse of that, we would just replace the y with the inverse notation. Next one is just asking you a little bit differently how to do the same thing. So just a reminder, switch x and y. I hope you notice the work is going to be the same regardless. So add 9 over. And remember to undo the 3/5 of y. Instead of dividing, it makes more sense to multiply by the reciprocal. Now, I really only care about the y-intercept. So as I move into slope-intercept form, I really don't care that the slope is 5/3 x. But what I do care about is that 9 times 5, or how about this? You can actually do 9 divided by 3 first, which is 3, times the 5 is 15. So the y-intercept would be option 1, 15. And there are other ways of doing this. I don't want to just skip over this, but for the sake of time, I might just touch base on, well, if the y-intercept is when x equals 0, well, if you want it of the inverse, you could let y equal 0 and then solve for x. That might seem weird to you, but that's another option. So as we move to point slope form, I'm going to talk about a few things. And maybe you've noticed on all of these, like when I went from y equals 2/3 to its inverse, we just did the reciprocal of the slope. I could go back to the previous example. The slope here was 5. The reciprocal of 5 is 1/5. So notice that you don't change the sign of these. So just real quick, I can already tell you what the answer is, because if I look at this slope being 4, I know the other answer would be 1/4 for the slope. So I already know the answer based off of a little deductive reasoning. Now the other way of doing this would be to literally switch x and y and then solve. So if I were to do the problem that way, I'll switch back to orange, it would be x plus 6 is equal to 4 times x minus 2. Well, how about instead of dividing both sides by 4, I multiply both sides by 1/4, and you could actually see the answer worked out that way. And I just switched things around. And there's other ways of approaching this problem, so maybe in class we can talk some more, or you can ask me in class. But I do want to move on to the next one, just for the sake of time and keeping this video somewhat short. So this is the graph of a function, okay, and they want you for the points, which of the following points is in the inverse. So let's talk about the point that's on this, because remember, it's y minus the y-coordinate equals the slope x minus the x-coordinate. So if I were to ask you what's the ordered pair, remember this thing, the x-coordinate would be -2, and then the y-coordinate would be 8, because remember it's the opposite. Okay, so all you can deduce based off of the inverse is that you switch x and y. So if I switch these two, don't change any signs, just switch them. 8 comes first, then -2. We're down to option 1 again. There's a lot of option 1s on this. Yeah, and I could think of other ways of explaining it, so maybe we can talk more about this in class, but let's keep it simple for this video. And the last one is asking which of the following linear functions would not have an inverse. So as a reminder, if you're going to have an inverse, this has been a while, but it was in exercise 1, it must pass the vertical line test and the horizontal line test. So as you go through some of these options, you know, y equals x is just a diagonal line, passes through the origin. Same thing with this next one. It's also a diagonal line, although the slope is up 1, right 2, if you were to solve for y. So still passes both. Same thing with option 4. You know, it has a steep slope, shifted down 1, but definitely passes both. But if you look at option 3, y equals, that is a horizontal line. And do horizontal lines pass the both test? No. A horizontal line fails the horizontal line test, which means option 3 would be the one that does not have an inverse that's also a function. If you're curious, its inverse would be x equals 2 if you switch x and y around. So that would be a vertical line, which is not a function, which is what we were looking for. So that's it for these notes. You should be ready to finish up these homework and get ready for the review coming up soon and the Unit 2 test.